We'll be starting now. The today's talk is on technology pillars for Industry 4.0 and smart manufacturing. And I think this entire series of webinar and masterclass lecture we are conducting under the Azadi ka Amrut Mahotsav celebrations for that our 75 years we have completed for Indian independence. So under that we are conducting this program also, today's program. So I think, as I told, I'm looking after various groups of CMTI which are working on smart manufacturing, also on precision machine tools and aggregates. So with this brief introduction, I will just take you over CMTI, what the CMTI has been doing over the years. So I think we started somewhere in 1960s, and we started as a R&D institution, basically focusing on development of machine tools and all. So various technologies which are mother technologies for development of machine tools, CMTI has been focusing from 1960s till today also. And but there was some few changes in the 90s. If you can see, apart from machine tool technologies, CMTI also has been working on various other advanced manufacturing technologies, such as additive manufacturing, nano manufacturing, mechatronics, automation, industrial vision, sensor technologies, and so on. I request all the participants to kindly mute yourself so that it is not inconvenient to other participants. Okay. So then further we have been working on more advanced technologies like development of textile machines, development of ultra precision machines, also machine tool aggregates. Also we have been working surface engineering. We are working now. Of course, we are working smart manufacturing and Industry 4.0. So basically, what our institute does. Actually, we work, between technology readiness level, the product development and process development from TRL level 3 to TRL level, 8 actually. So what we do actually, we from proof of concept to industry ready product, the development work CMTI does actually. And presently we are under Ministry of Heavy Industry. And we are autonomous institution, and our focus is to develop advanced manufacturing technology, as well as also to see that it is implemented in Indian manufacturing industry. So that is the way we have been working. So now let us see, if you see into this how we are connected with the smart manufacturing Industry 4.0, and today's talk is also on the technology pillars on that of Industry 4.0. So we are actually basically one of the common engineering facility center of Samarth Udyog Bharat 4.0 platform, which has been set up by Department of Heavy Industry. Now it is Ministry of Heavy Industry actually, and it's a Government of India program, and it is basically meant to enhance the competitiveness of Indian manufacturing industry, particularly in capital goods sector actually. So that is the way this platform has been set up, and there are many common engineering facility center apart from CMTI, which is working on Industry 4.0. So others are, apart from CMT, others are IIT Delhi, and then IIT Kharagpur, Institute of Science, and there is a lab also. So these all together, they have been working on basically on development of technologies, as well as also to see that these solutions are implemented in Indian manufacturing industry. Also, the centers, common engineering facility centers, are working towards awareness programs, training programs also. So now let us see what CMTI does actually as a common engineering facility center in Industry 4.0. So we are actually, if you see that all the centers, they have some common objectives, and there are some objectives which are different from each center actually. So at CMTI we have been setting up we are setting up a smart factory, which is basically a production factory, and also it's digital twin. just like a complete cyber physical system of smart factory, which is also going to do production. And digital twin in the true sense means we are looking into digital twin connecting design and production and the performance and maintenance sort of things in that, particularly for metal cutting and additive manufacturing and sheet metal cutting, manufacturing processes and machines. So that is the way it is be happening. And so this smart factory is going to be, likely to be ready by end of this year. Also, we have created a platform where development and testing and validation of Industry 4.0 and smart manufacturing solutions can be done actually. So that platforms it's there, and which we have been using for developmental works, as well as we are also allowing other people to make use of the facility. So also we have been working a lot on, because we have a lot of MSME industry, in manufacturing industries. So we are customizing and rolling out, smart manufacturing Industry 4.0 solutions for MSME. And of course, so our center is, that we call as SMDDC, Smart Manufacturing Demonstration and Development Center. So that is basically also it is like experimental learning center, where with hands-on training can be provided for both skilling and reskilling in this domain of Industry 4.0. So sorry. Just 1 second. I think. So now I will come back to what is technology pillars for Industry 4.0. So if you look into this Industry 4.0 smart manufacturing, that's basically it is a concept basically, and it itself is not a technology actually. So now when we are talking of Industry 4.0 smart manufacturing, it is propelled by many technologies. I mean, many technologies are there. Which are concurrent, and they are helping to that Industry 4.0 and smart manufacturing scenario and in the manufacturing industry. So let us talk about what are the technologies or technology pillars on which this Industry 4.0 smart manufacturing is standing, or which is helping this production solutions in this domain. So before that, let us see what is Industry 4.0. So let's look into that Industry 4.0, how it has been evolved actually over years actually. So I think Industry 4.0 is the industrial revolution of fourth generation sort of thing. So before that, we should also there was Industrial Revolution 1 long back. That was the first industrial revolution, and it was happened somewhere in end of 18th century. And what was happened, why it has actually happened is that at that time the steam power actually was people have looked into use of steam power based equipments and machines and all. So a lot of machines and things and productions this is started, which is equipments which are driven by steam, water and steam power. So that is the way it has looked into. So of course there was a limitation that equipment used to be bulky and the equipment needs to be near the source of water and steam power. Okay, this is the way it has happened. But I think if you see our steam engine and all that which is used in locomotives and all, that is one of the example of this Industrial Revolution 1. So later, after end of 19th century, the electrical energy use of electrical energy into machine equipments and all has been fully evolved, and then a lot of machines came which is driven by electrical energy. So then the mass production, batch productions of this thing started, and the advantage of this scenario is that electrical energy and all, it can be transmitted for quite long distance. We all know. So that's why that source need not be that that equipment need not be near the source also. It's easy to transmit electrical energy than steam power and water, this thing. So that way, so that has helped to come up many equipments, many industries which is doing mass productions and sort of thing. That was way back, somewhere in end of 19th century and all. Then came the Industrial Revolution 3, which is driven by basically, introduction of electronics, controllers, CNC controllers, PLCs, robots, and also IT in manufacturing. That was somewhere in Q4 of 20th century. In 1970s onwards, this has happened. And we all have been beneficiary, people, particularly the people who are older, they have seen that how CNC machines, how NC machines, how PLC based equipments and all came, and they started working for automatic production. But if you see that there even robots and all this thing came, but they were like robot was communicating to machine and so on. But there's nothing like a sort of like a concept of cyber physical sort of concept at that industrial revolution 3. So now next came the Industrial Revolution 4, where the concept has totally changed, and now we are looking into cyber physical systems. Not any asset, any equipment has its digital form, it has physical form, and they are connected to each other, through internet and all, or local server. So that is introduction of IoT or IIoT has come, which is connecting, all the assets, all things which is in form of cyber physical systems, they are connected to each other, and they have been also a lot of roles has been played by data analytics, which is driven by real-time intelligence, machine learning and all. And we are in the generation where we are working much more on virtual realities, augmented reality and sort of things. So these are the some things which make this different, industry 4 different than industry 3. So now if you see in our country, what we have scenario, we are going, we are going towards industry 4.0 and all, but still we have a lot of equipments, particularly in MSME, which are industry 3, and some of them are industry 2 generation also. So when we are talking of industry 4.0 smart manufacturing in our country, we have to look into that also, that we have to connect, we should be able to connect industry 3.0 generation, industry 2.0 generation equipments also into our in that our smart manufacturing processes and all. So that is possible. Okay. Now let us see what is the basic difference between traditional and smart manufacturing. So in traditional manufacturing also, basically we have been looking into mass productions and all. That is basically, and they focus on economic of scale. So higher the production and the lower the cost. That is the way this thing they are looking into that. But there are some drawbacks of that, and there have been also the quality controls and all. It's not that quality assurance sort of thing using control charts and process capability studies and all. So that has been there. It is there in traditional manufacturing also. But what is how it is different in smart manufacturing is that in smart manufacturing basically we are looking into entire operations, like entire productions and other verticals of organizations, like supply chain, also look into marketing, sales and marketing, and other quality assurance. They are all connected, integrated to each other, and everything is dynamic, and they respond in real time, which is not happening in the traditional manufacturing. Secondly, this quality assurance and all, which is happening mostly offline in the traditional manufacturing, they become in real time, that. And so there's nothing like, you can, that like after that one batch of this thing, components are produced, then you take some samples and then, check like that. In the smart manufacturing, these concepts are basically much more focused on real time, real time, and on machines, as far as possible on machines, the quality checks are done, and then real-time analytics are done, and accordingly sometimes even predictive analytics also done, that what is going to happen to quality in after some few numbers of components or few hours of operation, that is also taken care. So there is nothing like getting into defective or sort of components and all. So that is the way it is looking into that. And also this, when everything is digitized, all these processes are digitized, then it is very easy for to look into optimize the process based on demand forecasting and all. So that way you can overall manufacturing performance as well as productivity, efficiency can be improved. So that's the way it is different, these two concepts. Now, why we should look into industry 4.0? Let us see what is the need of this. So now what is happening is that as we are in the global scenario, and we have our manufacturing industry has to face global competition. So so that we can do only when our assets and every the manufacturing processes are digitized. The complete digitalization of this manufacturing processes are done. And that how it is going to help in that way, it is we have to look into the cost. This if you get into these concepts, and if you adopt these things, technologies and all, then the cost, we can eliminate waste and losses. Inventory, we can, hidden costs we can avoid, and then overall cost of the product will come down. So we can face global competition, and the cost will come down. And also that if you see, the products are becoming much more complex nowadays. So we are looking into components are multifunctional components and sort of thing. And also we are using nanotechnologies and all also have been used to in some of the cases. And complete assets, we are looking cyber physical systems sort of things. And so the complexity issue also can be handled if things are digitized. Changes are, you can bring out changes very fast if it is in digital form actually. And then the customer, actually you can satisfy customer, you can as the parts which are the components or the product will be it will come to customer faster, as well as it will be cost wise lower cost, and quality wise more cost quality. And you can sometimes, it is possible for customer to personalize its requirement. A customer can also, in some of the products, he can put his preferences, and accordingly the products will come out. So that's why it will give more satisfaction to customers. So these are things which are why Industry 4.0 is required. So now let us look into the basic design principles on which this Industry 4.0 or the smart manufacturing solutions or the products and the things are evolved actually. So basically, when we are looking into any product or solutions which is connected with Industry 4.0 or smart manufacturing, some of the basic things, design principles, we have to look into that. So let us see what are those. So first one is that we have to look into interoperability sort of concepts. So that can happen only when things are connected to each other. Means we have to design a product and solution in such a way that it communicates with each other, and using IoT or sort of thing. So every asset or every equipment should connect to each other, and also to humans and all through IoT. So that's the one thing. Then second thing is that virtualization. Means we should always have, for any product which is used for smart manufacturing or Industry 4.0, we should have physical, of course the physical product will be there, we should have a virtual copy of that also. So and as far as possible, sometimes in virtual we'll see that when we talk of digital twin, augmented reality and all, so using that virtual copy, we can do many things. We can do some simulations, we can do some shooting sort of thing, we can do some maintenance, we can provide training sort of things possible. Decentralization is another things which is looked into when we are talking of Industry 4.0 solutions. So as far as possible, decisions has to be taken close to the asset, close to the machines in real time. So real-time capability is the next one. So as far as possible, in real time things, we should be able to collect the information, what is happening on the machines, and we should be able to do an analysis why it is happening. And also we should be able to give some decisions which is decentralized. That is where we have to look into that. And then of course the service offering of services through internet and all, wherever it is applicable, that is also one of the most important aspects of Industry 4.0 offerings and all. And modularity, nowadays actually if you look into that, technology is fast changing, right? So we should be able to that whatever products and solutions are there, we should be able to adapt to the various types of smart factory sort of scenario. And also if any changes are there, we should be able to adapt. Means we should be able to make it should not become obsolete. We should be able to configure it and use it for longer time. There's a way we should look into that. So now let us talk of that. What are the things actually, technologies which are driving this Industry 4.0 or industry or smart manufacturing? So let us look into that. There are many technology. We have put some 10 numbers here, but you can find many more actually. So let us start with the sensors. So sensors are very important actually, and smart sensors and all are also very important, because the first thing in that, if you want to look into Industry 4.0 and smart manufacturing solutions and all, then we should know finally what is happening on your asset. It can be done through sensors, smart sensors and all. So that is very important. Then the other thing is that a lot of information comes from that when you are digitizing and we are sensing the manufacturing processes, a lot of data are generated. So we should be able to do analytics, right? So we'll have big data, and data analytics is very important when we are talking. This technologies behind this will play a big role when we are talking of Industry 4.0 solutions and all. So then the other one is that robots and cobots. So that we'll discuss, as you know, that, if you want to make the process more automatic, then robots and cobots will definitely help. They are part of, they play a big role in automation. Then other things are there, that are connected with a digital, form of your, asset or equipment. This connected with simulations are very important. I think we have been doing design simulations, so we know very well what is the importance of simulation. And then other things are there, like virtual reality, augmented reality, and mixed reality. So these are based on this technology, many solutions are offered in Industry 4.0 domain, which are very useful, and we doesn't require experts sometimes. If it can help you in doing assembly work, it can help you in training work, it can help you in maintenance work and all. So that we'll see, this thing. So this integration is very important in when and various techniques which are connecting, machine to machine connectivity and all, and also connecting one layer, one horizontal to another horizontal, and other verticals. So both horizontal and vertical integrations are very important when we are talking of solutions in Industry 4.0. IoT, I think IIoT, we know all, Industrial Internet of Things. I think most of the things we need to connect. We need to connect through server, local cloud, or through internet and all. So that's why they play a big role. Then, as we are talking of getting the information, a lot of information on cloud, and then it is playing a big role. So many cloud-based technologies are available that which are helping Industry Revolution 4. And then when a lot of informations are on cloud or internet, then definitely cyber security, various technologies are there for establishing cyber security and all. And apart from that, let us look into one more technique, which is, of course, it is on its own, is advanced manufacturing technology like additive manufacturing. So now when we are talking of fourth industrial evolution, additive manufacturing has played a bigger role, right? Why? Because in unlike subtractive processes, additive processes, in processes only, we have, when the process is going on, we have to take some decisions regarding the process, because the post processing becomes like a post process quality check becomes like a post-mortem in case of additive manufacturing. So in real time, if we are able to maintain quality and all, it is a big role to play. And second thing is that if you see in the additive manufacturing, it is basically based on the growing of the components and all, from design, from 3D design to a physical reality. So that fits very well into Industry 4.0. That's way. So these are some few technologies which are there. Apart from that, more technologies are emerging, which is not listed, like AI, ML and all, artificial intelligence, machine learning, and all. That gets into different type of solutions, like in sometimes in digital twin, sometimes in augmented reality sort of things, and sometimes in analytics and all. Okay. So let us look into one by one all these technologies which are driving Industry 4.0 and smart manufacturing. So IoT, as we know that IoT is Internet of Things, right? So any information or any device which is connecting through internet, it is IoT. But now IIoT is IoT technology. If it is for manufacturing industry, so then it becomes industrial IoT. In that, what happens that we have advanced connectivity of systems and manufacturing systems and physical objects and services which is provided from the manufacturing industry, and it is based on object to object communications and data sharing and all. So that is all possible, and that happens on the cloud. The cloud could be a local cloud, local server, which is within your factory, or it could be internet based cloud. So this is all about basic in a nutshell about IoT. So that's right. So that is the way it works, and definitely when with IoT technology, we can have it can help us to do analytics which are decentralized, and also decision makings which are in real time sort of things. It helps us to do that. So that is very basic technology enabler And then let us see this IoT, how it this thing it is, how it is a technology enabler in the, smart manufacturing industry 4.0. So let us see this, left side. We have like assets and all, which is we consider like the cyber physical systems, right? So that it is there in digital form, and we'll have physical form of things and all, machines, materials and all. It is in both physical and cyber digital form. It is available. So, and then it, in that machines and equipments, there are a lot of sensors and controllers are all there. So they all have some informations and all, so which is getting into as a form of data, and which is connected with either production or with the processes, so that we gets into that. So this is the thing. So we'll have, in machines we'll have sensors, we'll have devices, we'll have actuators. So they're all they all generate data or receive data sort of thing. So that is finally which is connected with productions or the processes. Then we have the IT part, which is playing role actually. So that is also there. So IT helps us to do some analytics and also cloud-based technologies, cloud-based solutions that can help us to generate and all. And then finally, the third part is the visualization, the outputs which comes from the systems. When we are in IoT based this thing, so the outputs income, it will basically it will come in terms of some reports and which is can be there on that your desktop PCs, or it can be on mobile, and which can give you information about the process efficiency, which is giving about something. It can predictive informations and preventive informations. It can also give information about real time sort of thing what is happening, and also it can help us to do remote management or remote controls and all. It can provide you. So there is a way look into that. So when we are talking of this different layer, different data flowing from from machine to that IT, and to that finally to the again from the output. So that connectivity plays a big role. The connectivity has to be seamless, right? So that way, so there are various the connectivity, the protocols are there, which is based on Wi-Fi, which is based, some things are based on wired technology, LAN-based technologies, and some of things are there in connected in through Wi-Fi and Bluetooth based, and also there's the various things are there which is enabling our data connectivities between different layers in manufacturing processes. Now, this is the way IoT plays a role actually. So now when we are talking of integration in case of this thing in industry 4.0 scenario, it plays a big role, right? So we have to look into both horizontal integration as well as vertical integration. So let us see what is horizontal integration. So horizontal integration is basically connecting of a connected network of cyber, physical, and enterprise systems that gives unprecedented level of automations and flexibility and operational efficiency into production processes. So if you look into that, horizontal integrations are much more be connected with production processes. Like you have suppose we are making some automobile company, some engine head, right? So all the machines and all which are arranged in a proper way, and to finally they are doing various operations on engine block. So that is all needs to be connected to each other, and that so has to be proper communications and sort of things. So that will provide you operational efficiency in the production process. So that is called horizontal integration. Generally within your workshop, actually, basically you can say, or maybe that way. So that whatever we do, it is all connected with. It can also include quality also, and that is that is the horizontal integration. Now, suppose we are this if and this horizontal integration can take place across geographical location also. Means factory, your production workshop at one geographical location and other geographical location also can be connected to each other. So that is the way horizontal integration is evolved. Now, vertical integration is what? Actually, if you see, apart from the production processes, there will be other logical activities in organization for connected with manufacturing. So it could be R&D, like, or could be design, it could be quality assurance, it could be product management, both supply, this thing, or even for sales order processing and all, it can be looked into that. So that is the way it has to. So if we are able to connect the production processes with other layers or other verticals of the organization, then we achieve this horizontal and vertical integrations, and then only we are doing smart manufacturing sort of things. And that can, if that can take into emerging requirement, if there is a change in the market market scenario or demand, then our manufacturing, entire manufacturing can adapt to that, and accordingly we can change our production. Means there are some 5 products from a company, and suddenly there is a demand of one product. So accordingly, the focus, the entire production processes and all can focus more on that the product which has more demand, and the product which has less demand, that can be in the can be number of components can be reduced. Like that, we have to we can achieve efficiencies. So same thing is shown in the that horizontal and vertical integration is shown in the here pictorial form. So we have a smart factory. We have various machines which are arranged as per process or as per the production line and all, and then they are connected to each other, and then also with quality assurance and all that is done within the factory, right? But apart from that, this factory, because when we are doing something, that we are making some components, and then finally we have to come out with a product, right? So then we require something, some other things which is bought out, right? So that supply chain is very big, plays a role. So according to real, just in time or in real time, based on the requirement, we should see that the supply chain is able to meet our requirement, and then we can, whatever components are coming, and then we can some bought outs and all are things we can add together, and then we can come out with a product which can go to market. Like that we have to see. Then this apart from that, if you see that how the that this thing comes, that what component has to be made, how many numbers has to be made, that is basically based on the customer, right? So customer, depending upon its demand and all, then we have to look into that that requirement, and then we have business process systems, ERP, we have design systems, that all will be based on that. We get certain inputs, then only the production process will start. And finally, again, back to when the components are made ready, they go back to the customer, So that is, so this entire things. So if there is any change, there is a change in the requirement of customer, then accordingly, entire things, will, adapt to that. So that is the beauty of smart manufacturing. Okay, so now looking into smart sensors, I think we know what is sensor. So so basically a sensor is a device which takes inputs from the physical environment, right? So smart sensor is also a sensor only. So it is taking inputs from the physical environment, and then what it does, it will have some built into some algorithms or some predefined functions it will have. And so based on the inputs level, or the information which is coming from input, it can take some actions, right? Or it can pass some signals to take some actions. That is way smart sensors we are looking into that. And in case of Industry 4.0 and smart manufacturing scenario, we'll have plenty of smart sensors which are there on the equipment or assets. This thing. So that's the way we look into that. So that is the things about smart sensors. So now let us look into that. The sensors, smart sensors are sensors, how they communicate to your local server or through IoT, internet-based this thing server and all. So let us see that. We will have different machines, and every machines will have different type of sensors. Which can sense the temperature, it can sense the force, it can sense the power, it can sense the energy, it can sense the vibration, it can sense the speed, many things, or it can sense the pressure, it can sense the flow. So, and also, if it is like a manufacturing process, we will have robots and cobots. So that also will have many sensors and all. So that need to get connected to other assets also that way. So now the sensors, from the sensors, whatever informations are coming. So some of the information directly goes to the PLC and CNC and all that, and from there we can take the information and we can take it to local server, local cloud, or internet-based cloud. Like that we can do that. All then sometimes what happens, there is some these things, that it will have that directly goes to some IO link sort of devices, and from there information can also pass it to either wired or wireless to this local server or internet-based servers. Like that, it can also happen. So there are various way of using both wired or wireless methods by which the sensor information can be taken to controllers as well as local clouds or internet-based clouds and all, okay, for analytics and decision making. Also, when we are talking of the sensors and all, I think what is in Industry 4.0, the first thing what is important is that we should correctly map what is happening. We should be able to visualize what is happening in our machine or our asset. So that is achieved through sensors. And if you look into that various physical phenomena which is happening on the machine, which is connected to temperature, pressure, flow, torque, power, vibrations and acoustics, emissions, velocity, even RFID sort of this thing for getting the information about the part and all. So they will transmit that data at different sort of like sampling or different frequencies actually. So we need to have proper techniques to acquire the data and do data samplings in a proper way. Like in case of temperature, for example, 10 hertz, is enough. But when we talk of vibrations, we need to collect data at 20 kilohertz. So like that we have to see. So proper data acquisition systems and proper communication methods are required. Protocols are required, and when we are nowadays in the wireless, right? So when we have to transmit data at a very high speed and all, we have to see the proper techniques and proper protocols are used to do that. So that's why. So nowadays, people are, because based on that, wherever there is a lot of data, people are talking of data processing at edge only, close to the machine, rather than taking all the information to cloud. And that will be much more problematic. So only the process information which is done at local edge controllers, some of the information which is post processed and can go to cloud. Like that, people are also looking into that. So now let us look into that other these things, technologies which are driving our Industry 4.0 in the proper way. It is that robots and cobots, right? So what is robot? I think we all know, we have been seeing robots from last almost 30-40 years. So it is basically most of the earlier generation, they used to be autonomous robot, right? So what it does, it will do a variety of tasks with high degree of autonomy, right? And they can interact with machines also, and but only thing is that they're I mean, they do monotonous sort of work, so which are repetitive of nature and all. Now came the cobot, right? Cobot is a collaborative robot. So what it does, cobot can also interact with human and learn from them. And see, in case of we might have been seeing that when robots are working, so there will be sometimes they will put a cage around that, so that people should not hit by people and all. If they are people should not get into that so that, because it works autonomy. If you put your hand in between, the robot will not know that it is you are putting your hand, so it may hit you. But in case of cobot, the concepts are different. It is supposed to work with human beings and learn from them. So that is the way. So that once cobots have come, so that number of industrial applications which can this cobot can serve has become much more. So now cobots can be used in conjunction with human beings for doing assembly work. Okay, so part of that, he will it will give you something, and then you do something like that and work together each other. And if it is coming near your hand, you can tap them, or they can sense your hand or your limbs and all, and they will not do any damage. So it is it is providing us a greater range of capability, right? So that's otherwise we know that robots are used in variety of applications. Pick and place, I think it is very popular. Then robots are used for part of like assembly and inspections. In automobile companies, we know that robots can be arranged in line, and then each robot can do some few works, and then other robots will do remaining work, like that. So plenty of possibilities are there. Robots are used for even nowadays for welding sort of thing, and it is also used for painting sort of thing. It can be used for machining work. robots are nowadays are also used for inspection. Plenty of 3D scanners are mounted on robots, and with that conjunction, we are able to do a lot of reverse engineering work and inspection work and all in sheet metal and components and all. So a variety of opportunities are there for robots to work. And of course, so it is conventionally it can do also, it can do some it can drive some tool, it can do some drilling work, that sort of thing also it can do that. So there's a way look into that. So now let us look into a typical type of robots and cobots which are used in the industry. It is the most common is articulated robots. So basically articulated robots will have mostly the rotary joints and all, and generally it will have around 6 joints. So you get with that you will have more, I mean almost 6 degrees of freedom you will have. So that is the way it works, and these are quite common, quite popular and all. So that is the way most of the thing what we see, it will have robots will have rotary joints and 6 degrees of freedom, and we are of different capability, and it can do. So it can do speeds. It can work at very high speeds, and it takes. What is the advantage is that it is more flexibility, and it can it takes less work less floor space, and it can have large workspace. Like that way it can, and variety of work it can do it, right? But the disadvantage of these are that some programming are robots and all that they require, you have to convert, normal way of programming, it gets into converted into which is understandable by robot, right? So there is a mathematical algorithm which is converting your Cartesian programming into robot, movements of joints and all. So that is the way. So that is the inverse basically based on inverse kinematics and all. So there is there. Apart from this robots, articulated robot which is on joints and all, we have Cartesian cobots. So it will have basically linear joints and X, Y, Z. So it can, but it has some limitations. Although it can work, move, speed, it has better positioning accuracy. And but the thing is that it will have limited applications when you are talking of Cartesian robots actually. Then the SCARA robots are there. I think the SCARA robots, selective compliance assembly robot arm. So if you see, these are something like wherever that your work volume is like a donut shaped work volume, then it works very fast. It will have some rotary joints which is parallel to each other, and so that way, and it can work very fast, very high speed it can have, and that is the way it is working. And for some of the applications, it has found to be very useful and lower cost also, this SCARA robots and all. We have a Delta robots, which generally you will find nowadays in some inspection and pick and place sort of applications. So a lot of CMMs and other things they are coming with end effectors and all, and also that which is on Delta robot based sort of thing. So what it does actually, if you see in this Delta robot, that you'll have parallel joint linkages, right? So you'll have one end and other end, and in between you will have parallel joint linkages and all. So the end effector will be, or that it will be at the other end, and this is the base. In between you have parallel joints and all. So it also has some applications which are basically for pick and place and for inspection work and all. So like that, we have plenty of robots and cobots configurations. But one more important is that when we are talking of robots and configuration, then we are talking of various applications, right? Some of the applications are pick and place. Some of the things are connected with assembly work. Some things are connected with machining work. Some things are connected with inspection work and all. So then the end effector, that is which is the end of the other end of the robot. Which is used for operations and all, that plays a big role. So in some terms we call gripper and all, but end effector can be much more than gripper. It can be other types of end effector apart from grippers and all. So you will have, in talk of grippers, you can have different type of grippers. It could be mechanical grippers, and it could be magnetic grippers, vacuum grippers, and grippers with adhesives and all. So and also then can be different type of configuration. You can have two finger configuration, you can have 3 finger configuration, and this how it actuates these fingers and all. It can have parallel, or it can have angular motions and all. So it is a variety of things are available, for depending upon the shape of the job and the tool. We have variety of options for end effectors, right? So accordingly, we have to select proper end effector to do a particular applications. So that's why it makes much more versatile when the end effectors are there together with cobot and robot. It makes it much more versatile to solve to help in a variety of industrial applications. Okay, now apart from robots and cobots, automated guided vehicle AGVs also plays a big role. And so what is AGV? If you see, AGV is basically something like a mobile robot, and which can move on that shop floor, following some tracks, and or it can have some sensors or wireless sort of thing, and also it can it can also basically it can have some robots also which is mounted on that, and together it can it can do variety of operations. It can take jobs from one warehouse to machine to machines. It can do loading of the jobs from from its pallet to the its own top this thing pallets which are mounted on top of AGV. There it can load to machines and vice versa. So a variety of things are there actually. So it makes factory automation. So very important that AGV and it is very important for entire factory sort of automation work. So nowadays, if you are looking into AGVs, they are coming with sensors, many sensors which are mounted on that. If you see the first generation, they used to move on the wires. They used to track the wires which is there on the floor at that time. Nowadays, they are coming with vision. They are coming also, and they are becoming much more intelligent. AGVs, they will have sensors, and they will which works on the wireless networks. So, and these guidance mechanisms and automatic controls are happening in a better way. So that is a way, and so that way nowadays the light-weighted trackless AGVs are being rolled out. So that is the also coming into play in automation in the factory environment. Next technology which is driving Industry 4.0 is simulation, and then next simulation, the other advanced part is digital twin. So okay, so now when we are, I think we are all familiar of design and simulation. So before the physical prototype is done, we do design work, right? And then we do analysis. Design analysis we do using CAE tools and all. So now let us see how it is this thing. So we are very much familiar with simulation, and we also know why simulation is done, right? Simulation is done to know how this thing, your product or the asset or whatever that this thing is going to behave in the physical when it is put in the physical operation, right? That is the way we look into that. Much more before prototyping is done, right? So that is that. So that is very useful too. Now, when we're talking of digital twin, it is basically making this that cyber physical machine or cyber physical system in a true way. See what happens that you have a digital this thing you have physical asset which is prototype, and also you have it's digital twin. So digital twin actually basically it is mapping all the physical properties of your like connected to materials, connected to dynamics, and connected to mechanisms. Everything is you can visualize in the digital part of that. So it is that way, and also it is taking in real time. It takes some inputs now from the physical asset. Means through sensors are mounted. I think we know very well that plenty of sensors are there in the physical system, so that those informations are going to digital also cyber space through cyber space and cyber model. So the digital model, and with this connectivity between physical and cyber, we can instead of doing some test on the physical prototype, we can do on the digital twin. So that is the way scientists and R&D people, so they are they are working they are finding that digital things are very useful. So some of the things we can do it. And nowadays digital twin is technologies are driven by IoT and artificial intelligence and analytics. So that way a lot of things we can do in digital twin rather than doing on the physical system. Anyway, so now let us look into that. How it is these concepts are in research. So this is small aircraft, and then we have it's digital twin. It is for this thing I wanted. It's not a picture. It is the complete some digital form of these systems, which is having all the informations required connected with the physical behavior of the systems and dynamics of the systems also. And also that whatever sensors and all mounted on that, and whatever actuators are there, that can be that is giving inputs and taking inputs and giving inputs in this system also. So if anything is happening there, it will reflect there also. That is the way it is connected each other through IoT and this thing. So now, instead of doing some test there, we can do it here in digital twin, okay? Because it is really, it is mapping the behavior, that dynamics, thermal, and sort of static dynamics, thermal behavior of the physical system. So that is the way we can do that. Digital twin can be used. Now next is augmented reality, which is that they are in the family of that virtual reality, augmented reality, as well as the mixed reality. So they are all. So we'll just discuss about augmented reality. What is that? So what is that actually? Augmented reality, it is basically this based solution they will provide engineers and workers and the people. They can interact with the physical system with real-time digital information, right? And also they can take some decision. So unlike digital twin where we can do some testing and all, here it is other way. Using augmented reality, you can it can help you to do some maintenance work, or it can help you to do some assembly work, or it can help you to give training sort of thing to your employees and all. So that is the way. So it and also it can help you to support some other activities like in warehouses also, such sort of thing, selecting which components. So what you will do in that, if you see, we'll in this using augmented reality, we'll just take a, like, this is a tab. So using the tab or using this thing, mobile camera, it will take you, suppose it's a machine actually. So you take a picture of the machine. Suppose you are looking into workhead of some machine, right? So then if you take a picture near that, so it will show you what is inside, and also it can give you the details, how, what is that for maintenance guys, which bearings are there, and all. Also apart from that, also it can give you some information which is coming through sensors, like what is the temperature and sort of things. You can see that. And also based on that, you can also interact. You can also give your decision, like maintenance engineers can give some inputs using the proper software which is driving the augmented reality. Likewise, you take like a control system or something. If you take a picture, then it will start showing you what are the circuit diagrams, some manuals and all, which is connected with maintenance and all. It will all information it can show you. So that is the way it works. So likewise in assembly, suppose if you are doing a machine assembly, so it consists of variety of parts, right? So once you go near the assembly bench and you take the picture of one part, so it will tell you which other parts are coming, which fasteners are required, and how to apply, which tools are used, and which bolt we have to put first. Like all the information it can provide you using the augmented reality software. Very useful tool. Now coming to another technique, manufacturing techniques which are getting merged into our smart manufacturing, additive manufacturing, right? So I think we know what is additive manufacturing. So it is growing, unlike your subtractive manufacturing, we grow component, 3D complex component. We grow from powder or the wires and all, and we get a component. So from design to physical shape, we can achieve very fast, right? So that is the thing we are doing. So, and industry 4.0 with that technology, we can grow the components, quality components, right? In additive manufacturing, I was telling, a lot of things depends upon the process actually. So in there the process control and process monitoring plays a big role. So that and then only you can get quality products, right? So that's why with industry 4.0 it is possible to get quality small batches of products, right? Which is that way. So now let us see that what is the role of 3D printing or additive manufacturing. So now with this, what is happening is that our focus is changing. From the design this context to higher level of components to the system, right? So when we look into additive manufacturing, we are looking into consolidations of our design activities, and so that this and the components which we bring it through 3D printing, it can have multi-functions, or it gives you a lot of design freedoms which are not possible in subtractive processes, right? And some of the concept like design for manufacturing, design for assembly, and all that can be looked into in better way when we are talking of 3D printing actually, right? So let's see example actually. So this is the one sub component which is used for Volvo trucks. So so that is there. So it is basically for traditional constructive manufacturing. It was having 28 components, right? So that way. With additive manufacturing, we are with only six components we are able to realize. So like that. So it gives you a lot of these things. You can reduce number of components. It gives you a lot of freedom when it comes to design, and you can make the components multifunctional and all. So that you can achieve through this one. Now let us see that so that what is the role of cloud, and cloud based computing, right? So why clouds are very much popular in that in the industry 4.0 smart manufacturing? Because what happens that this cloud based technology will help us to connect and share the data across the geographical sites and company boundaries. So like companies, suppose one company has one factory at Bangalore, one other one at Ghaziabad, or other one at somewhere in Kolkata. So they all can connect, and that that we can share the data. Decision makings can happen across the boundary and all. So these all can be achieved through cloud, and cloud-based computing, right? So when a lot of informations are going to cloud, then we have to do there's a specialized tool so that we can get the informations in millisecond response time, real time and all. So that is a lot of cloud-based technologies are there. So many service providers are there, which some of you may be knowing already. So Amazon is there, AWS, then Azure from Microsoft. They are all basically providing services and all, which is using this cloud-based computing and cloud. They are also giving cloud space. So now thing is that another thing is that data analytics plays a role. I think so if you want to know, and apart from that, what is happening and why it is happening, and what is going to happen, then this analytics plays a big role, right? So nowadays analytics are based on machine learning, also artificial intelligence and all. So that these things are going to help us real-time decision making, right? And also there are some analytics which are based on edge analytics, which is very close to the machine, near the machine. And some of the analytics are there which is through cloud, so that people take a call. I told you, based on the data and data sampling rate and all, people will and importance where the node redundancy is requirements. You have to take decision in real time in milliseconds. Then we have to go for edge analytics sometimes. So that will help us to take decisions faster, and that lower and the cost also can become lower, right? That is the way we look into analytics. Cybersecurity, I think we all know that what is importance when the lot of informations are going to the centralized server, which are there on the cloud or internet, right? So then I think that these informations are sometimes we are doing business, right? So our informations are confidential. So that should not go to other. So that way there are a lot of techniques by which we can protect the data. Also within organization itself, people at different levels, they need to access a different part of data only. So operators, they need some information. Supervisors, they need some information to look into, and managers, they look into some information, and the MD and all, they will look into some different type of information and all. So these all are possible through you providing this cyber security and proper access to users and all. So now coming back to CMTI, let us see CMTI, what we have been doing. We are setting a smart factory. You can see that component comes raw material, and that is being tagged with RFID tagging, and then it is recognized what operations has to be done. And accordingly, the components are moving on AGV, loaded through robot to going to different machines. And then finally, after all the operations done, it goes for inspection. Some of the inspection take place on the machine itself, but there are some inspections which are taking offline. That after that, and then it is inspected fully, like using CMM and all some of the features, and then finally everything is okay. Then in that case, it goes back to the to warehouse or to the store. Like that, it is happening. Then it is all these machines. If you see that, they are all connected to each other using these lines. If you can see that, we have these lines and all. So they're connected to each other through wired network using LAN or wireless protocols. it is connected to each other. Apart from that, there are some devices which are mounted on the some sensors and some devices which are mounted on the machines, where that information from those sensors can directly go to the server. This way, and otherwise we have PLC, we have CNC. To that different communication protocol, we are taking different informations and we are connecting to each other. And also every information is going to like a local cloud server actually, right? And then also we can put into internet-based clouds also. That is the way we are looking into that. So now this is the way it is there. So now this is one part. Then apart from that, this is we are also monitoring, you know, that all the machines in real time we are monitoring, and we are knowing what is happening and why it is happening and what is going to happen. So that way also we have, you know, diagnostics, we have prognostics we are doing on all assets and all, and also we are monitoring like you know, energy and all, what is the energy consumption sort of thing, and we are finding out operational you know, effectiveness and all, productive improvements, optimization. So variety of things are possible when we are having this type of you know, connectivity and which is driven by Industry 4.0 technologies. So like that we have been doing. So this is the factory at CMTI which is going to come up, and I think by end of this year already some assets are connected and we are demonstrating. The complete factory will be demonstrated by end of the year. So now let's look into that the benefits of the smart manufacturing. Why it is so important and all. Finally, what we get from this thing if you look into that. So we you know, definitely the product quality is likely to be better. That is the thing in this scenario of Industry 4.0 and smart manufacturing. Why? So we can not only we can, you know, in real time we are monitoring the quality and we are not allowing any defect. Apart from that, we can predict also. We can predict the quality trends, right? So that is possible. So that way, and in real time we are able to take corrective action. So it is nothing like most of the technologies are based on in such a way that in the, you know, defective things should not go, and rejects also should be minimal, right? So that both way it is going to help the product quality. Now coming to the cost, definitely the cost, you know, why people are talking so much on this technology, that cost I mean comes down. Like why? Because we have lower inventory level. Like we need not have to have much inventory for either for tools or for raw materials and all. So it is based on the demand of the customer. Accordingly, that materials and all happens. According to that, we should have procurement tools, and that also maintenance inventory we should have minimal, because we know what is going to happen, when it is going to happen, like that. And then we are doing, you know, proper scheduling. We are seeing that OE losses, the losses which are you know, going to which are contributing to our overall equipment effectiveness, they are reduced, right? So that is the way we are looking into that. Material handling cost also will comes down, and we are also monitoring energy and all, and as far as possible we see that energy wastages are not there. So like that, these all will help us to reduce the cost. Finally, the cost will come down per component, right? Productivity, right? So productivity is going to improve, right? So it is one of the focus of the Industry 4.0 smart manufacturing. So this, when everything is you know, connected and, you know, smart, and then so there is a lot that whatever that in between that whatever that bottlenecks are there, and there are some things which are waiting for some operations, they are all avoided, right? So this is a smart and connected system will definitely improve the you know, operational efficiencies, right? And second, why the productivity is improving, that we have real-time data, which is, you know, which is available to the manufacturers. So when to produce, how much to produce, they know that. And this entire system, if you see smart factory, you can adapt to the demand of customer. So that way we can adjust to the orders, right? So that is the thing. And same time, we will not produce which is not going to be used in a short time. So that is the way we have to look into that. So that way the overall productivity improves. So when there is overall productivity improvement, then obviously the efficiencies and all will go improve. So we'll have optimized solutions. We have higher productivity. We have lower cost and all. On-time activities we are doing. we are correcting, we are applying some corrective measures in the real time using predictive maintenance and machine learning algorithms. So that way, so entire system is having very better agility, and then it's become much more versatile, and that's the way we can improve efficiency and all. That's the way it is there. So now this is the last slide of my this thing. So we have discussed about the various technologies which are driving the industry 4.0 and smart manufacturing, right? So we have to use proper technology based on the machines, generation of machines what we have at our factory. Suppose you want to implement, right? So then the first thing is that we should see which are the machines which are of industry 4.0 generation, which are industry 3.0 generation, industry 2.0 generation. Also some assets are there. So how to implement that is very important. So the different sort of the technology pillars which I have been discussing so far, that has to be used. So to see finally that there are all assets are connected to each other in some way. Like for example, so now if you take that new generation control machines, CNC machines with new generation of controllers. So by default, they will give you a lot of connectivity, and they are based on open architecture, motion controllers and all. So and it gives you connectivity. You can tap a lot of information from the machines using some standard connectivity protocols, right? So that way we can do that. But there are some old generation CNC machines, and there are some machines which are not CNC also, right? So then how to do that, and what to do? That various techniques are there. We can be adopted. Just for example, take a machine which is not CNC at all, but still those things you can connect. You know how? Because you can do, like, any machines will have some motors and all, which will consume some energy. You can do energy monitoring easily. There are some gadgets and some devices available which can be mounted on the machine, by which you can do energy monitoring, right? Then you will have you need to check that vibrations and things for maintenance work, or some other things. You can add some sensors on the machines, low cost sensors and all, and which we can have both wired as well as wireless sort of connectivity. You can take the data information to that. So that way we can connect those assets and all. It's not that those assets cannot be connected which are not CNC also. So that way we have to look into that and to see that the benefit we get it once we join all assets in the obviously there in the factory. Then we can get maximum benefit, right? Is the way you look into it. So now coming to implementation part. So industry 4.0, as you said, that basic thing actually, the basic thing is required for doing industry 4.0 smart manufacturing is that as far as possible, we need to have some digitalization of your assets and the manufacturing processes. So we need to do that. So then that is a basic thing. So once we are able to do, then only we can move towards industry 4.0 at different this thing. So that level 1 of industry 4.0 implementation is a basic thing. We should know that what is happening. So that how we can know? Because we can know through sensors mounted on the machines and taking the inputs from PLC, CNC. We can know that what is happening on the machines. Okay, so that is the thing. Then the next part is the diagnostic part. Then once we know what is happening, then that is also very useful. It can help you to know your productivity, effectiveness, or energy consumption. That this information, what is happening, that a lot of benefits can be obtained. The next part is that why it is happening, right? Diagnostic part, right? Then we can do some diagnostics and why it is happening. We can do some maintenance related activities is very helpful. Health monitoring, we can do it, and also sometimes in case of productivity, that if our operational effectiveness is low, we can know the reasons why it is low. Management of that can be possible, and after these things we can do that. The next is that suppose we are able to do that, then what is going to happen and what will happen. So that we have to build predictive analytics and predictive capability we have to build. We can know the residual life, we can know the predictive quality, we can understand. So that is the way we can go in next stage, right? Okay. Then the next is the adaptive control and self-optimizing, right? That can happen. definitely using, of course, machine learning, and a lot of machine learning and AI tools are used to achieve this. So this is a way Industry 4.0, a different level of implementation. We can get different benefits out of that. So this is that about my lecture today. So thank you for patient listening. And now I think it is open for any questions and all. So I request if anybody has any questions, then you can ask me.
Okay,
Okay.
just
I
1 minute.
Yeah.
Before asking questions, we would like to inform you that we have a YouTube channel in the name of Smart Manufacturing. I will share the link of that channel. So you please subscribe to that so that you get regular updates. Now, Mr. Prakash Vinod sir is available to answer your questions. If you have any questions, you can ask them, or else you can post it in the chat box so that the questions will be answered through the offline method. Thank you.
You can have questions in your chat box if that we can answer. And I think we should request people to, those who are participants, they should please kindly, I think, feedback. I think you are posting any feedback form, Anwar?
Yes, feedback form, it's already been posted.
Yeah, so that you need to fill. If you are looking for certificate, it becomes much more easy for us to, if you fill the forms. So if you have any questions, please let me know. So I will stop sharing my presentation, and then I leave it open, okay, for any questions. Okay, is there anything in the chat box, Anwar?
No, sir. As of now, nobody has asked any questions.
Okay. So if there are no questions, then I like to thank all the participants for patient listening. And as I mentioned, that we are conducting a series of masterclass lectures, webinars, and some other events also as part of that Azadi ka Amrut Mahotsav, which is being celebrated because we completed 75 years of Indian independence, right? So under that we are conducting a lot of programs. So I request you all to please look into CMTI website as well as Samarth Udyog. There is a website, Samarth Udyog website also, so you can look into that. Also, the CMTI has got one portal, Drishti. There also we are putting a lot of events information. So please subscribe to that also. And as Anwar was telling that there is YouTube channel, so you can use that also and look into that, all these things. And if you have any questions, please feel free to connect with us anytime. So we'll be able to take up the questions later also, offline also. So thank you so much for patient listening, and I like to thank my CMTA colleagues also. So that for organizing and and helping me to deliver the lecture. So thank you all. And if before I end, I again request you to fill the feedback form for it will help us to generate these e-certificates quickly. Thank you all.